Next is an activity for you to practice sketching vectors. So what I need you to do is I need you to take the desks and push them all the way to the outside of the room. So you have a big empty space in the middle of the floor to walk around. And I need you to break into small groups. Usually pairs works best. Sometimes groups of 3, but pairs is actually the best way to do it. So grab a partner, move all the desks out of the room, and when you're ready to go, start the video again. So the best way to do this that I've found is for you to get like a little scrap piece of paper and to place it on the floor, and that will be your starting point. Kind of like we did when we did the example in the room and we had somebody stand on the colored tile. Unfortunately, there aren't a whole bunch of colored tiles on the floor. There were only a few, so it's not going to work for everybody to find a colored tile. Sometimes you can find like a bump on the floor and that can be your starting point, but somehow, some way you need to get a mark on the floor to be your starting point. And if you're desperate, just grab a scrap piece of paper and set it on the floor so you know where you start. What you're going to do is you're going to have one person do the walking of the vectors, and the other person is going to draw on a piece of paper what the vectors should look like. Included in there should be the resultant. So what we're going to do is we're going to walk the vectors, we're going to sketch them on the paper, and then we're going to do like we did with the example in the room where we counted. If we went in a direct line, usually it's a diagonal line, if we went in a direct line from the starting point straight to where you ended, what would the resultant be? So what I'm going to do is I'm going to put the directions up here for the first one. And we're going to kind of walk you through the first one together. And then I'm going to let you do the other two and we'll compare answers after we're done. So here's the first one that I want you to do. So from your starting point, one person is going to walk 3 squares north. Once they've walked 3 squares north, then they're going to do the next vector, which is to head 3 squares to the west. Now remember, I believe Mr. Farron has an N on one of the whiteboards, the one in the front of the room by the smart board. And then he's also got an E on the other whiteboard over by the demo table. And so that should help you out when you're doing your north, south, east, and west. Once you've headed 3 squares west, then the next thing you're going to do is 3 squares north. Now, while that was going on, the person with the paper should have had a dot on the paper and should have drawn an arrow that represented 3 squares in the north direction on their paper. And then the person walking started where they left off. So you're going to start your arrows where you left off. So this is what the arrows are going to look like. So here is your starting point. You should have an arrow on your paper that goes 3 squares north, and then start where you just ended to do the 3 squares to the west, and then start where you just ended and do the 3 squares to the north. The resultant is a dotted line that goes from the start immediately to the finish, and usually it's a diagonal line of some nature. Now, on the floor, I wanted you to count how far you were. And again, if I were in the room, my foot is about the size of a whole square, or you can approximate it. That's basically what I want you to do. This in no means is a mathematical answer. This is just an estimation. So if you're somewhere close to 6 squares-ish, give or take, definitely at a northwest direction. And you notice how I have arrows on each of my vectors? This one went north, so there's an arrowhead on the north end. This one went west, so there's an arrowhead, so I know it's pointing west. This one went north, so there's an arrowhead, so I know that it's pointing north. This one, the resultant, has an arrowhead on it as well at the finish. That's where the arrowhead goes. And that would be pointing northwest. To find the equilibrant again is that tug-of-war concept where you don't want the flag in the middle to be moving. So the magnitude portion is going to be exactly identical. If it was 6 squares here, it's going to be 6 squares down below. Now, if you got 7 squares, there's nothing wrong with that answer. This one should say 7 squares then, and this one should say 7 squares. They should match whatever yours was. But the directions are exactly the opposite. So if this one was pointing northwest for the resultant, the equilibrant would be pointing southeast, exactly the opposite direction. So what we're going to do is we're going to do another one, except this time I'm not going to walk you through it. This time, Mr. Farron is going to hit pause on the video, and you guys are going to do it yourself. Now, I'll give you one slight tip before you get started, though. Remember for this second set of directions that because the south is written first, you're going to, wherever you're standing, face south and then turn 45 degrees towards the west. It goes in order. So go ahead and press pause and draw. I would switch people. Whoever walked last time should be doing the drawing, and whoever did the drawing should now be doing the walking. And there's a reason why I have you walk it, and that's because if you get stuck, it seems to make a little more sense to people. Now, why have I titled this Treasure Hunt? I think of it like somebody giving you directions on where to find the treasure. The end is where the treasure would be. Now, there are some people who would say, oh, that's not that far. Why should I walk all those stupid directions? I could just walk straight to it and pick up the treasure. And that's the resultant, walking straight to it and picking up the treasure. So go ahead and hit pause on the video now and walk this one and draw it. Now, let's just compare our sketches. Now, remember, these are sketches, so it may not be perfectly identical, but it should be pretty close to this. My arrows should be proportional. So where this is 5 squares, it should be much longer than the 2 square. The 2 square should be about half as big. A 1 square should be much shorter. Notice that there are arrowheads pointing in the direction that I'm supposed to be going. If the treasure were right here indeed, and I started here, how many steps would I have to take if I just walked straight to the treasure without following the directions? That would be the resultant. I believe it should be somewhere in the range of 7 squares-ish. Again, this is an ish assignment. It shouldn't be exactly the same, and it should depend on where you were at and how you walked, etc. But whatever this number is for the resultant, remember the equilibrant has to have the exact same magnitude. So I got 7 squares at southwest. That's the direction where the treasure would be. My equilibrant would be 7 squares at northeast. Same magnitude, opposite direction. And now for the next set of directions. Again, just a little preface before we get started. Whenever you see this number and there's no north, south, east, west, this is one of those directions where you're going to start north and turn clockwise a certain number of degrees. So you're going to keep going from the north all the way around to the right in the clockwise direction until you have traveled 270 degrees. And that should be the direction that you draw your arrow. Remember, this one means 45 degrees east of the south line. So face south and then go to the east side of it that many degrees. Go ahead and draw, walk, switching spots again, and we'll compare answers in a moment. Okay, so here's what my picture looked like for this particular one. 270 degrees happens to be west, so my first arrow that I drew from the starting point was west. I was facing south and I went 45 degrees to the east side of that line. That's what those directions mean. And so my next arrow looked a little bit longer at 4 squares, and my last arrow was 2 squares north. Now this one is kind of tricky because everybody's sketch always seems to look a little different. My dotted line resultant with an arrowhead at the end where the finish line was looks like about 2 squares, maybe 1, maybe 1.5. Remember, this is an ish assignment. And mine looks pretty close to south. Now I've seen some people when they draw it, it looks a little more southeast. I've seen some people when they draw it, it looks a little southwest, so it kind of depends on how you drew it. But whatever it is, the equilibriant should be the same numerical value, and the directions should be exactly opposite of each other because that's what would equalize it or balance it out. Now, the next assignment that you're going to be given here in a few minutes is a worksheet where you're actually going to draw out 4 of these on one of the sides of the paper. So it's the side of the paper that's numbered 1, 2, 3, and 4. This is an ish assignment. You do not have to walk it. If you understand what's going on, you may just draw it. People that do things incorrectly, one word of wisdom would be that you have to make sure that wherever your previous arrow ended, that's where you're starting and drawing your next arrow. Wherever your previous arrow ended, that's where you start drawing the next arrow. That's a common mistake that students will do. The second thing is, if you get stuck, stand up and walk it. I promise you, if you walk it, it'll make a lot more sense. The answers to that particular assignment are ish answers. Yours should be somewhere in the ballpark. Sometimes I'll use my pen or my pencil to approximate how far something is. So if I drew an arrow and it was about this big and that represented 10, sometimes I'll take that and I'll use that. This is 10, that's 20, oh, it looks like about 25. So sometimes I use my pencil to help me measure. Some of you have rulers in your planners. Feel free to use those to help you measure or approximate a little better if you feel like you need a little more control over it.